Okay, we are on. You come to the site. You click the button. You count to roughly 15. You wait for Xerothermic Chimpanzee to load. Eventually, it's waiting.
No, that's all right. It's got a lot to do at this first point.
Waiting a little bit more. And here we have Xerothermic Chimpanzee. Busy loading. Here is Codex.
Okay.
Hi. Then what you can see is we go MCP. We have the local MCP server, which connects in interaction await, interaction cancel, interaction start. These are the functions to do agent-to-agent communications. These are the functions that I have demonstrated to you in the past, so we know that the bots can interpret them correctly and can spawn off agents at whim to do their bidding. The difference in the demonstrated version was that it was all on a single computer. A single computer being one of the most subtle forms of prison that programming has ever invented. But this new version jumps across computers. Jumps across virtual machines.
Yeah.
The downside is that these functions, they don't exactly work. You get a slight error just now, but I'm in the process of tracing down why that is, and I think I've got it sorted. It is this block of code here. As you can tell from the comments, there is signs of a struggle, and I am it's basically if I fix that bug, then I deal with the next bug. But if I fix that bug, then it will make these functions work for the agent that you're on. And if you somehow happen to know the remote agent that you want, then it should also just work for them. And I need to move forwards. The next step is to add a class of actions named the agents functions, which is going to be to call up the catalog of agents.
Yeah, cool.
I already have that working in testing, so that's under agent kinds. So these are the kinds of agent right now: test, inspector, codex, and command. All of those work locally, and the victory, even though you can't see it, is that each one of these has been tested in isolation within my development environment. This thing indicates that I can load one of these agents or any of these agents in a remote computer on demand from the browser. And so getting all of that to work together was the challenge. And now that it works together, all the other connecting up the bits are relatively cosmetic. So it reads. Sorry.
In that agent file that you're just in, you're saying that they're all local, but I think you're hinting at that it didn't have to be local.
Yeah, because the way that I've broken up or modularized the code is that any project in here that starts with agent dash is meant to be something that someone who wants to make a new kind of agent would expand and build. So you see how they map exactly to here, like agent test, agent inspector, inspector, codex, CMD, CMD. And so this is like the thing that you just build lots and lots of different bits, versions of. They all have different skills, different features,
Mm-hmm. Mm-hmm.
like inspector.
I didn't see an Agent Tommel there.
There isn't one. There isn't one because, and I'll show you why.
Mm-hmm.
If I exit out of here and I show you the running agent, and I go to the Codex home directory. So this is the home that you see. This is the NFS home, right? Mount computers. We're in the test computer under agents. Xerothermic chimpanzee home. If I list everything here, this is all the stuff to do with Codex. But if I go here, there is agent.toml. And
Okay.
this is the agent.toml that loaded the agent that you just saw boot.
Gotcha. Right. Okay.
And so its command is to say, okay, you got the command is dino run -a main.ts, and the directory to do it in is the agent codex directory, which is this directory, agent codex. And so what it means to say is that even when you have your agent agent.toml, then like this is not the place where you write code. This is the place where you write config. And so you need to point to the code that you want the agent to run, and that's what this whole folder is all the code that you need to make that kind of agent work.
And what is the sysprompt called?
So the sysprompt is unique to the code. So, like, for example, agent inspector wouldn't have a sysprompt because it's not an AI powered agent.
Mm-hmm.
It's just the MCP inspector. Here is, for example, this is the config file that Codex uses. One of the key phrases in here, I think it's called experimental like use and there we go. It's something like that.
It's interesting using experimental, but okay.
It isn't experimental. But that's just where they're at, right? Like that they have hard coded the prompts of Codex in here, and so for this particular bundle of code, we would tell it where the instructions file was, and we might describe some custom fields here. Like I could either pass in some environment variables that the code was going to look at. Like it might look at, I pass in an environment variable and tell it where I want the instructions file to be. Or it might be some custom fields or some custom config. If you want, we can make it like a semi-standard field. So the way the config file is laid out now, agent is really just a way to say how to run this MCP server. But if we also assume that optionally sometimes agents will have sysprompts, because that appears to be a constant across all the AI models that we use, then I can add an extra thing in here that would say would be optional, and it would go agent.sysprompt, and then you'd like set a path or something. Well, you could either
another file.
A path to a file, yeah,
that makes more sense.
So, and then the file needs to be either something that's set up here, or you can point to another location on disk. It kind of doesn't matter. I'll be honest with you, it's a little bit sloppy to me what the best way to handle that sysprompt location is, but I'm confident that the optimal way will sort of shake out. You can
can
see
give
that
you
there are many
I can
options.
give
Like,
you I can give you a view, but this is just a view, not being
okay,
deep in this. What I'd like to do is say if I wanted to create an agent, I would talk to an agent creator
yeah,
who would set all this up and would ask me questions, like,
right,
what environment, what model, that sort of thing, and then ask, okay, so do you have a sys prompt for me? And it's like, no, that's fine. I would null it out. Doesn't matter. Or I have a sys prompt, and then after that, I would only be editing the sys prompt file. I don't want to mess with the
yeah,
config
yeah. That's right. That's
because
right. So the sysprompt definitely shouldn't go in the config. I think that's a pretty
yeah, because
standard
you
thing.
could easily have your cat walk over your keyboard and delete some of the config, and now suddenly it doesn't work. And it's
It
like,
also sort of,
again,
like the config is not intentionally messy, but it is the interface between the software and human readable. So you sort of don't want to have too much information in there. Like these are very powerful variables, like one keystroke different and the whole thing won't work.
uh, exactly. So when we do this agent create thing, um, it asks me suitable questions and gives me options. It's like, where do you want
Mm,
to run this?
mm.
What model, etc. And there's going to be others, and then it sets up these files. I never want to ever have to go in and edit any of those
Yeah,
files.
that's right. That's right. You should never have to edit these files.
But the sysprompt, I want to be able to mess with all day long.
Yep. So I think that the best way is, yeah, I'll add an extra key here because the idea is that you're supposed to also have things like tools, and then that's where you can add extra MCP servers. They can be either local or remote or whatever you want, and that
Yep.
you chuck them all in there, and then that's what the agent gets loaded with.
Yeah, and again, what to see that is, again, this is very sketchy, but when you got the agent create agent that you're talking to and saying, hey, do you want any tools? It's like, I don't know what a tool is, what's available to me. It's like,
Right,
well, you can do these things. It's like,
right.
oh, what does that do? What does that do? What does that do? It's like, right, okay, you got these. What do you, what's this agent's purpose? It's like, it's this. It's like, right, you've forgotten a tool. How about adding this one? You probably need that.
Yep, I think this supports that exactly.
Yeah, cool.
Um, there doesn't seem to be any other way. Like I can't think of a way to do this system without the agent.toml file. So yes,
Yeah,
we'll have a bot that writes it. I mean, obviously, I already have a program that writes it because that's how this file got here, just by me visiting the browser page. But there there needs to be a vibe coding bot that knows about how to build it, how to test it, how to
yeah,
how to
I have to kind
gather
of suggest saying,
requirements.
and also when you're, and this is a bit more advanced than what we've just been talking about, when you're using the agent and you're trying to do something that requires a tool that is not there, escalate it up and saying, hey, do you want to add this tool? But
Right.
again, you never
Like
want to open.
a self improvement in the background thing.
Yeah,
So there'll be like a workbench to build agents, but then there also needs to be a workbench to build agent patterns as well, because
yeah,
assembling them together seems to naturally follow from this. Like as soon as I have one, I want many.
yeah.
And so this config file needs to be expanded to have some notion of being in a team. I don't know if that needs to be a different type of config file or if we can simply expand some of the fields here to say that this agent is a member of a team, or to say what children it has, or if it's a totally separate thing, like a template file, because what I've sort of been wrestling with is that the agent file at the moment it's very mutable and it sort of gets generated on the fly. But in reality, I think you'd want it to come from a library where the library included some code that helped it run, like the harness, some base sysprompts, or at least some sysprompt options that you could choose from as a consumer of this thing. You're like, well, these are the popular sysprompts. You'd want some MCP tools, some of which might be remote, and you want that package to be not completely dynamic. You want it to have had some use and some testing, some stability.
Yeah, there's also an angle there where inheritance of sysprompt would be helpful. So
Sysprompt inheritance, I hate that because that makes it really difficult
uh
to, like, you've just sort of brought one of the worst features of coding into the,
okay, all
you
right.
know, like,
The reason I'm saying is like if you set up an agent, you don't want to sysprompt every time I work for Goldman Sachs, and there's some stuff that is invariant across multiple agents that you don't have access to doing that part. It's always going to be sysprompted for that, and then you add into that.
wouldn't that be just how the agent builder was configured, and it would pull from these standard sort of blocks of knowledge that it had to insert, and that's the builder doing that?
It could well be.
Like, if
Yeah,
you
that
have inheritance, then you're implying that the inherited file might change from underneath you, and now you expect it to run the latest version.
well, yes, I guess if you just been Goldman Sachs has just been bought out, and then it says, "Oh, I'm now
Yeah, you
working
don't
for."
want to. You don't want to add that. Like,
Mm-hmm.
the thing, because the sysprompts are plain text, they can be parsed as plain text. But as soon as you add inheritance, now you need all the ills of dependencies. Like dependencies.
I guess what you could do if you segment out the sysprompts, then there's nothing to stop another agent looking at all the sysprompts inside of a tree and saying all the agents inside of this tree now need to conform to, you must
Yeah,
do
yeah.
logs
Like,
of
you can.
this.
That's right. You can do an order. You can do like a mass transform. You can manage the paragraphs of different parts of the sysprompt and say this paragraph always has to be exact, and you can do your versioning externally so that the sysprompt is portable. So the key feature I wanted out of the agent file was that it was a portable identity for that agent. It wasn't something you just made up on the fly. It's something that is long lived and is instanced many times because it's been found to be useful. It's not a once off thing.
Yeah, no, I agree with that.
Because
Persistence
otherwise,
is
like, what are
really
you
the
what are
key.
you building on? Like, how do you what's the point of an improvement if it just gets thrown away? You can't
Yeah,
evolve in that environment.
yeah.
So
Okay,
that's why the agent file, like, it seems
quite a gnarly
simple.
one, isn't
Yeah,
it?
I know it seems simple on the surface, but then you're like, I think the design choice is portability, unitary. It doesn't have
Oh,
dependencies. Like,
it's
it's got a dependency on a code package here. It's got a dependency on a set of text instructions. It's got a dependency on these environment variables. That's it. I think you could leave it alone at that point.
there's hmm, there's a thing about the portability because it might be ported to somewhere else
Yeah.
with different standards.
Yeah, and so you want, like, portability and patchability are related. Like it's hard to patch something with deep dependencies. It's hard to pick it up and move it when it's got all these dangly bits all tangled off, hanging off the side. But if you had this one bit and you just like, move it, and then you can dynamically patch it as you require it, it's not, it's not,
Yeah, I mean, the thing is,
anyway,
if
look,
you,
these
yeah, yeah,
kinds of
okay,
issues are
yeah,
you could probably argue about these issues for weeks on end. I think the best way is to just pick something pragmatic and then just see how it feels, and then if you don't like it, we'll change it. Like it's just
well,
not.
the pragmatic thing is a single sys prompt, and yeah, sure, you
Yeah,
can get a meta agent looking at it
yeah,
and saying, does that conform to our
yeah, because
rules?
that's the um that's the phase change that we're up against now. Is that we're not here to write a software system. We're here to write just enough software system that we can have agents that dynamically and livelily do the work. And so one
Yeah.
such example is in the management of the Git repos. So managing a Git repo is a bit of a complicated thing on a good day. For example, if I say git help, each one of these, you get my point, right? Like,
Yeah, most users would like go, don't know.
right. But you can also shoot yourself in the foot pretty
Yeah,
easily. But
yeah,
then if you picked a subset of these commands and made them into MCP tools, then you would be lacking some power. So what I've sort of really come to you with is, see, then you've got like the GitHub tool, where the GitHub tool deals with oh, what did I do? What? The GitHub tool deals with how to interact with GitHub, like issues, orgs, projects, like so. There's really this like super deep, complex thing here. But what I wanted to suggest to you, um, if I can just detach from this current path and then tell you what I was thinking about, and I
mm-hmm.
promise you it all links up.
Mm-hmm.
Um, wait a second, wait a second. Yeah, the code base is probably about as big as I ever want it to be. Like it's
Mm-hmm.
enough that I'm like, where did that bit go? And it's not really that good. So we've got the tooling for the interactions, right? Like the description. This is what the bot gets. Await the result of a previously queued interaction. Um,
Yeah.
then there was the agents thing, right? I was like, well, you got to have the MCP tools to interact with agents on the platform. Surely must be catalog agents, i.e., what
Yes,
agents can
discovery.
I
Yeah,
have?
yeah.
List the agents given a computer ID, so what agents are actually active. So in our case, if I go up one and I go, this is all the agents that are running in this computer.
Uh-huh.
They are not alphabetically or any kind of anything thing. So we had xerothermic chimpanzee. I think we had ugly lungfish,
Yeah, there it is. Yeah,
selfish
go down.
squirrel. No, I know
Yeah,
that one. I just
yeah.
wanted to. There was probably the.
Magnificent halibut. These names are hilarious.
Yeah. Anyway, I can't find it. One of
Eagle,
these was
eagle
awesome. It
township.
was like religious prawn or something, and it like I was like that was the one that was the first one I booted yesterday.
Uh,
Aggregate vulture, did a lot of work in that. Bumpy turtle, hey. So anyway, xerothermic chimpanzee. Um, this is all these agents are on the same file system within the computer, right? So in these are all the computers that are here. These are the computers that get auto-generated when you log in using
mm,
uh, using Clerk, Fat Leopard, and then yeah, like you end up with. So I'll go back into the test computer. We've got the agents, xerothermic chimpanzee, right? So oh, why is it not working here? Can you just give me a sec?
mhm.
Oh, that's right. Yeah, exec. So exec is where the live running things are. Okay, so xerothermic chimpanzee is the file that's used to represent the hardware. So the
Mhm.
software bit says the the software or the agents, they want this agent to be running. The hardware,
Mm.
which is the software that reconciles the intended state of the software with the actual state of the hardware, it says that the hardware is running. Obviously,
Mhm.
the how this agent's host was created was that this was the Docker image file that it was built from
Mm.
using a shared CPU with one CPU and only 256 megs of RAM. Machine
Mm.
ID is the key thing. You'll notice that at the prompt here, the host name is the same as this
Mhm.
machine ID. So this is basically the piece of hardware in Fly that is running. So when I come back into Fly, I hope you understand or
Yeah.
see all the moving parts that are going on,
No.
right?
Yeah. Yeah.
Like,
So yeah, there is. There
yeah.
is.
So
Yeah.
helpfully I figured out a way to name it so that it matches the name, right? So anyway, that's xerothermic chimpanzee. It's booted. It's got a IPv6 address. This is the image that it loaded from. You got stats. You got all this stuff, right? Um, a cool feature that I put in is I can go stop. So as I see, it's reconnecting. So I've killed or simulated a crash of xerothermic chimpanzee. It goes
Mhm.
red to say it's been destroyed, but then moments later, back comes xerothermic chimpanzee. Totally different
Mhm. With
machine
a different
ID.
ID. Okay.
Yeah, and it's still booting, still booting, still booting. And now it comes back and it remembers what we last said.
Oh, that's nice.
It
That is
comes,
very,
right?
very nice.
It
Yeah.
recovers where you left off. So when your agent either crashes or it gets shut down due to idle. So I've given these things a 5-minute idle time. The machines will be destroyed, but then as soon as you want to talk to them again, they'll get booted and come back, and then they'll pop up exactly where they were before, and then you're ready to go.
So all you need to do is remember the URL, and you don't care where it's running.
Yes and no. You don't even need to remember that because what you should be able to do is say something like, show me all the agents that have done something related to fish in the last 2 weeks. And then theoretically, that should use this set of functions like list agents, agent status. So it's like, what has this agent been doing? So it would use one of the MCP tools to browse through the list of agents and then find the ones that had been doing something relating to fish, and then it would tell you, Angry Vulture has,
Mm.
and then you'd be like, oh, yeah, switch me over to that, or tell it to carry on, or something like that. So the fact that you get assigned a name when you don't have any clue. This is
Mm-hmm.
your entry or your landing agent that
Mm-hmm.
will guide you and help you now that you have tools to get back to what you were doing last. Like, yeah, these names are randomly assigned. They can also be explicitly assigned. Like, you can have the Rogan Josh agent.
Mm-hmm.
They
Mm-hmm.
can be named as you wish.
But you don't really care if you can do, for example, show me all the agents that have done anything in the
Yeah,
last 2 weeks.
that's right. That's right. That's right. And so what I'm trying to lead up to here is there's a set of functions. This is the agent set of functions. I already had these functions working in the previous versions, so I know a lot about the details of them, and I
Mm-hmm.
believe they'll be very fast to make, like a couple of hours type of thing. That'll let you interact and manage your agents. I'm not entirely sure yet what to do about agents on another computer that you want to interact with. I'm hoping that will sort of shake out.
Mm-hmm.
Um, but the last set of functions I want to walk you through is a set of functions for repos. So
Mm-hmm.
in a computer, we have. So if I go to the Mount Computers, we're in the test computer repos. There are no repos here, but the theory is that a repo is something that is this is the canonical Git repo, and in each agent in their workspace. So I go agents, Xerothermic Chimpanzee workspace. In that folder will be a set of repos that you told the agent to work on. Like, this is the
Mm-hmm.
context of the agent, right? And so the issue is that this is the start of the complexity explosion that cripples all software,
Mm-hmm.
because it doesn't make sense to make each agent so skilled in the art of Git that they manage the Git repos themselves, or at least
Yeah.
I don't think it does. I might
Yeah,
be
no, I
wrong
agree.
about that, but the point I'm trying to make is that managing a Git repo is a complex business unto itself. And there's
Mm-hmm.
two paths we can go. We can either make more and more software, and in our world, that's more and more MCP tools that an agent can call that will do deterministic things. So
Mm-hmm.
the rule seems to be make an MCP tool if it's going to be a deterministic thing, and if there was no decision making involved. But
Mm-hmm.
um, the that's all well and good in principle, but as soon as the job gets complicated, the number of tools explodes, and then you defeat yourself by having a large number of tools. Agents like the Deep Research Agent and Codex show us that a small number of tools, so Deep Research has two tools, search and fetch, is extremely effective. And then Codex shows us that a command line, where it will sort of fumble around, can do remarkable things. And so the question, the philosophical, the artistic cut line is to say, when have we written enough software, and when should the features we want out of the platform be handled by an agent that was specifically prompted and given the tools and then tested to do the thing, right? That's
Mm-hmm.
really the point. And my theory, more philosophy on it, is that it should be as soon as fucking possible, which is now. So,
Mm-hmm.
for example, managing the Git repo, when you want to set up a Git repo, your agent talks to the Git manager on the computer, and the Git manager knows about where the repos are stored in the computer. It knows about GitHub and how to use Git and the tools, and it's made to adhere to the standards that are laid out by the computer. So that agent is not freely editable. Like, it shouldn't be something that you can accidentally change the sysprompt of, because it's a system service. It's something that you depend on for features, because the alternate is to do it in code, in which case the same kind of authority is being pushed on you because I write the code and I publish it. That's the same as saying I wrote the prompt and I publish it, right? It amounts to the same, but providing it agentically means that, first of all, I have less work to do. Second of all, it's more adaptive. Second of all, the tool interface becomes plain text. And so to use the tool, all you got to do is sort of loosely grab it by the head and speak to it, and then it will do the thing or tell you why you asked the wrong thing or you shouldn't do the thing, which is a stark contrast to how a software tool responds to you. A software tool, you got to read the help file of the subcommand, try that one command. Oops, that was an error. Like, it's not, first of all, it's not safe. It's a big surface area to program for. It requires constant maintenance. It's not very durable. Like, it as your requirements change, the interface has to change. But providing these core services agentically is much more adaptive.
And it seems it's going to benefit from the improvement in LLMs as they come through.
Well, these types of tasks, like a service level agent, feels like it's pretty much there. Like, it'll do good work and it will do it quickly.
Yeah. In terms of where the cut is, I agree. As soon as you get into the agent prompted understands what the system is being asked to run, as soon as you get into that part, then it's far more robust than baked code. Because with baked code, maybe something will change if it's an external system.
It becomes tough. Like, it has a toughness about it. Like, it also, I think the correct term is ductile. Like, when it starts to break, it stretches. It doesn't crack or shatter, or it bends with the situation. So that was what I was sort of coming to you with. And I know that this is historically, you and I have made many systems over the years, actually, if you were to count back on the number of times that we've like been like, do this thing, and we're like, yeah, do it. Oh no, that was a bust, right? Historically, the point where we start to say, okay, the code's done and now it's the bots, that's always been a very rocky, that's been probably the catastrophic point. That's the point where you either know it works or it doesn't.
Yeah.
So I guess the safe thing to do is to say, well, it's easy and cheap to try it agentically now, so do it. And then if it's too early or too raw, then we'll just add software until it isn't. But I think that the general principle is I think we can set ourselves a philosophical goal or a design razor that says, we should be trying to reduce all of the code down to a absolute minimum set of MCP tools that are controlled by some agents, and all of the other features should come from agentic interactions, patterns, and hierarchies.
Because those patterns can then have robust checks and balances in that are driven by bots that, for example, I want this to happen, and that process triggers the, our guardian angels.
The guardian trips.
did that work? It's like,
Yeah.
you got that quite a bit
Yeah,
wrong.
so to have an effective guardian, you kind of just need the ability to back out,
Yeah,
and optionally a checkpoint. And
yeah,
so the sooner we can become agentic in our inner services, the sooner we become more like an intentional computer, where you signal intent and you really don't give a hoot how it manages to
precisely,
do it. You're just like,
precisely.
figure it out, right? So
Yeah, but also the dark side of that coin is you also don't want to be the one who, as a human, has got to spot a tiny error because it's gone off on one, or there's been a small change that is actually incompatible, and so on. You want another agent to say, red flag this. It's like, that didn't work.
yeah, which kind of leans on our deeper goals of self healing, right? Where the system's monitoring itself and it's watching over time, and when any kinds of perturbations occur, it can sandbox them up and theorize about them, and then re-health the system, like
Yeah.
re-up.
Yeah, yeah, and
That's
the first
right.
step of that is like is gone
Heal.
wrong,
It can
and
heal.
therefore, what are you going to do about that, agent? It's like, all
Yeah,
right,
yeah, but
I
that's
know, I
the
know,
that's
I know a
the
guy for that. Yeah,
that's the
like,
inner cycle that keeps going even when the humans walked away from the computer. It's
yeah,
like healing is one aspect of self improvement. There's like keep going for better eval scores, but there's also our eval score says we failed, like that's an error. So keep going until you fix that, right?
yeah, yeah,
Yeah,
precisely. Because
yeah.
the part of the philosophy we're going for um, is to reduce the cognitive load as much as possible from the human.
Yes, but also from the programmers of the machine that's trying to make
Yeah,
software for the human.
they're just humans as well. Yeah, they're
Yep,
just different humans from
yep,
the active user.
yep, yep.
Um, As soon as we get into that space, then we've got as many tokens as we want to burn. We
Right.
can churn over this. We can find new, you know, unique ways of doing this. We can self heal and so on. And it's like, boom. Okay, so sorry, boss, that took 2 days. It was meant to take 2 minutes. However, you asked a really gnarly question there, and we solved it.
Right. So, um, what I wanted to point out then, since you sound enthusiastically on board about it, is that that model of making the computer services be delivered by agents is a pattern.
Yes, it is.
So it's like a pattern computer where it's sort of got, like we've started arranging the agent blocks to deliver the services of the computer, which is why I pause on saying how agents would communicate between computers, because it might be that there's like a firewall pattern that manages or marshals the communication between the two computers, as
Oh,
opposed to
there's definitely going to be some kind of perimeter
a
inside of
perimeter,
which
right? Yeah.
you're going to be okay with agents. Outside of which it's like, wow, it's the Wild
The
West, to be
perimeter
honest.
the perimeter needs to be maintained. You can't just expect each individual agent to manage its perimeter. There needs to be an oversight, that has special powers to restrict the perimeter, but an impervious perimeter is actually no use. You need a perimeter that can selectively open at times. That's
Right. Yeah. But the fact that it's opened, well, let's use port to talk to Wild West agent. He doesn't know whether it's
yeah,
bad or good.
no.
Um,
Right, so you need the
However,
semantic firewalls to be detecting things like prompt injections and other types of
right, right,
bad
right,
behavior coming in, right?
and also maybe tagging in his response saying, "Hey, we talked to this guy, this other agent is outside the perimeter. The last 5 times has been right, but this isn't out. Take it with a pinch of salt.
Right,
Um,
right,
but
right.
inside the perimeter, we're far more confident about what the agents are doing
That's
because
right.
they're, 'They're, inside of our control.
Yeah, inside the perimeter. All right. So what I'll do then is the question the sort of stall for me was that repo model where I was saying that a computer has repos. So here, um, the computer. This is the agents of the computer.
Oh, you're
This
not
is
displaying anything.
oh shit. I'm sorry. It's because my computer logged me off, and I
Uh,
felt proud in that I developed a solution to get around the fact that I can't use my facial ID while I'm wearing this fucking thing on my face. And so what I figured out was I've got a fingerprint scanner on my phone that unlocks my computer. And I was like, haha, finally I got to use it. It worked. And then I forgot to share the screen because it had been disconnected. Anyway,
okay, that's good.
all right, so the three
Yep.
components that the computer has at the moment: agents, which represents the static snapshotted data of
Yep.
each agent, which is home, which represents its sort of special config, its safe whatever.
Yep. Yep.
Workspace, which is the broader context that is its own dedicated branch in zero or more repositories, and
Yep.
then agent.toml, which is obviously its config. But then you've got exec, which is I'm going to rename that to hosts, but actually that represents all the running machinery, all the running virtual machines that are active in this computer, so
Mm-hmm.
that you can. A good general rule seems to be that a hypercomputer should be able to be represented entirely by a git commit, and you should be able to fully restore it from that commit at all times. And
As
so,
you just demonstrated, yeah, in
right?
terms of going back to the tin.
I
Yeah.
know, right? It's like
Yeah.
it's like a crashy way of doing things. Like you expect the apps to crash all the time. They're meant to
Yeah.
do that. And the git commit is effectively a quiesced snapshot of the running state of the machine. Um, exec is important because you could delete exec when you go to spin up a new version, but exec is important so that uh, the bookkeeping has to be done somewhere. I figured it might as well be done in the computer itself. I could
Mm.
always split it off to be the host, but now the host is special, right? So that's why what I've done is I've made even the host is just another computer. So the thing that runs the hardware is just another computer, and it stores its accounting data in the primitives that are available to any other computer. So
Oh,
repos is the storage primitive. And so repos is the folder that holds the full blown Git repo. Like that's not a dedicated branch, that's all branches. That's the credentials, that's the remote path for the repo, that's the latest
mm-hmm.
commit, that's the everything about it. Now it can be cloned from some other location like GitHub or GitLab, but it can also be a server of repos too. So I could make a repo in my computer called biography of one, and then you could clone that into your computer because I would be acting as the server or the reference. Um,
Right. Right. And I would need an endpoint for that storage to
yeah,
happen somewhere.
right. I'm the
Um,
endpoint. I'm the endpoint there.
yeah. So in terms of this persistent repos are basically persistent storage, right?
Right.
So um, I could set my own uh, repo server, and I would know that the stuff I'm doing there is always going to persist. I could clone yours, but that everyone knows, you know, after that, if you make changes,
Yeah. Yeah.
but
You've diverged and you need to synchronize.
yeah, um, but where if I wanted to fork what you're doing, where would be the storage?
Repos.
Mine or yours?
Your computer, your repos, because you would have cloned from me, and then you've
Yep.
either diverged in the main branch or whatever branch you were working on, or you made your own branch for your computer, and then that stayed separate from me, and you can PR against me, and you can merge in my changes and whatever. But each agent has a branch dedicated entirely to that agent. So whilst each agent is aware of the other branches in the repo,
Hmm.
specifically it is given an isolated branch with which it can work on freely.
Okay. All right. And then say if we're running a, I don't know, payroll system,
Mm.
and I'm HR or whatever, you're the accountant or whatever, and I want to run a few things as the HR. You need to consolidate at the end of each month, and so on. We're still effectively working in the same knowledge space, but
Hmm.
I'm not going to piss over anything you're doing. And
No,
my
because
first,
it's all just repos. Like if we were in the same computer, even that's totally fine because each agent has its own branch, so there's no collisions. But if you're on different computers, and it's even finer because you have even less to collide about.
so what would a merge look like? Say if I did a
It's
bunch of
just a regular.
spreadsheets,
That's just a regular Git merge.
and I could do that from the my agent here
One of the
to,
agents that had the conflict could work through the conflict.
yeah, I'm going to say, right, okay, I'm
Hmm.
done working now,
Yeah,
push this
but
up
that's
to,
that's an example of where the agentic patterns can apply to like Git project management patterns, where you can have a pull request master or a project manager that receives all these pull requests from these different agents, and then can be in charge of merging them and figuring
mhm.
out the differences. So it's a way to make it so that the humans never have to deal with merge conflicts
Yeah.
because you're dealing with them agentically. And so like I believe that there's I don't know what the number is, but it feels like less than 40 different software commands that you need in terms of MCP tools, and then the rest can be entirely agentic, where agentic also includes making specialized agents that have totally different tools. But I mean like system level functions, right? Like so in Linux, you take like the syscalls that you can make is basically the kernel interface that you get given. That number of commands is not that big. I don't know the exact number, but I think it's around about 50, something like that. It's
Mhm.
it's old for one, and it's
Mhm.
stable, and it's agreed by everyone, right? And that's the system interface. There feels like we got this thing with managing interactions, managing agents, managing repos, and managing computers. And if you can do manage those four types of resource, um, it feels like that's all that you ever need to do, because everything else is something that happens inside of those kinds of resource. Like if you want to open the firewall up, that's just your agent talking to the firewall agent and negotiating using text. Um,
Yeah, yeah,
if
yeah.
if you wanna set up a video call,
It speaks. It's almost like a new adjacent ISO layer, isn't it? It's like the agentic layer.
yeah, but ISO was a stack. This is more like the fact that each layer needs to talk to each other layer distinctly. Like as an agent, you might want to talk to the interagent comms layer, the repo layer, the computer layer, um,
Yeah, you're
and
right. Which is
you
why
know
it's kind of I said it fuzzily there, but by adjacent it's like um, similar to. Um,
it's a sort of
you're right. It's
it's a
like a
reduced
circle.
principle. It's like a very tiny number of things, and too little, and you lose the ability to make some particular moves. And too many, obviously, and you've clearly missed the mark. And the bots get confused because they don't like large number of tools. The humans get confused. The bloat grows on and on and on. But the key seems to be this ability to self-host, or the convergence of the system, where I can manage the hardware that runs all the computers from within another computer. And that's only made possible because the levels can communicate with each other. Like the agentic level can communicate with the computer level. The computer level influences the agentic level because it turns, machines on and off. It controls the perimeter. But that level jumping is what makes the convergence possible. And I don't know. I can't think of any other types of resource that you need to add to the system. I hope that that's enough, and I
Mm.
guess we'll just have to see, right? Because
Yeah.
it definitely works for agentic problems, but not all problems are agentic. So, what does that mean? Like there may be some classes of problems that don't fit into this model so well. We'll just
Well,
have to see.
anything. If you were like a supercoder, typing very fast, you could do everything that we've just discussed. If you're like some kind of genius, uh, so everything that you're doing, the razor cut seems to be there is um, if there's a piece of code that's well tested, as
Mm.
in been around for decades,
Yep.
you know, that's just something that you expose as a tool to agents. How you orchestrate those, definitely agents.
Yeah, but it's like not this is just the system, the syscall layer. The like the rest of the system can be arbitrarily large because, for example, you can expose it to a Linux shell, and it's like it's got everything. It can also pull down new packages. It can write its own packages. It can write code and call code, and do all that. So that space seems unlimited, but the
Mm-hmm.
number of syscalls you need to manage the coordination of the agents to perform patterns feels like it's able to be restricted and then jealously guarded. So you've got like it's only these 14 tool calls. That's what the system definition is. And
Mm-hmm.
not every agent needs every type of tool call. Like an agent can be, you must have the interactions layer, otherwise you can't be controlled. Like you need that control harness. But
Mm-hmm.
apart from that, um, you're not obligated to have access to any of the others.
It does feel that there's a remarkably small number of fundamentals, isn't there?
That's what I'm hoping. Because it feels like a kind of a graph where if you've designed it wrong, it amplifies too much, and the number of individual things you need explodes.
Mm.
But you got to have some things, otherwise you miss out on the features you need. And the only way we find that is we game out situations and we try and use it for things, and we're like, oh, it doesn't do this type of thing.
Mm.
But this feels like enough, I think.
It feels right. Why does it feel right? It feels a bit like the old style calculators. There's
Like
only
the
so many buttons there.
BFX. You're right,
Yeah,
right, right.
yeah. But you can do remarkable things. Now, you got the simple calculator. Mm. Okay, but you can still do stuff. The
Mm,
scientific calculator, some of it was there in order for you to not have to type in so many things. So it's convenience.
right.
Um, but above that, what the calculations you're actually doing is very much in the agent world.
Yeah. So the design principle is try and be agentic as soon as possible, even for computer level things, because I think it just works out better.
Yeah, yeah, yeah. And then it comes down to checks and balances, just in case.
Yeah, just
You
in
know.
case, right? Which is
Yeah.
what we're banking on. Like we're banking on the ability to have reliable agents that have checks, and it's not so dissimilar from human processes where you have like gatekeepers and separation of duties and all that. Like, you can make a
Right.
reliable system out of humans, even though each individual is unreliable and prone to error. So it's really just incorporating those principles way down at the fundamental levels of the system.
Yeah, but even
Um,
those, even that pattern seems to be fairly stable. For example, NASA got to the moon by using human computers, mostly black women by the looks of it, writing out, doing maths,
yeah,
handing over to someone to check. There was another one who was, then proving that the results of all those
yeah.
checks and
That's
all the
right. That's
original
right.
calculations and
That's
so
right.
on.
That's right.
But there's only 2 or 3 steps,
Yeah.
and it feels like it's that.
Because the thing that
It's
we gain there is that by keeping the code complexity low, first of all, we can deliver features much faster because we're delivering them as plain text. Second of all, it's easier for the bots to tweak. Like, code is very unforgiving,
yeah,
um, and also it's hard for humans. I find it hard to read a bot's code because a bot can easily make very verbose code that works quite well. But as a human, I'm like, oh, ouch, like my brain, like that doesn't, I know that works, but like it's painful to read. But reading like a sysprompt feels a lot more understandable because it's softer. It's more um,
ductile.
ductile. Yeah, yeah, and so I think the bots are better at writing sys prompts to fix their own problems than they are at writing code too.
Hmm.
So it
Yeah,
sort of feels like a great way to skip a huge amount of burden from providing a reliable and up to date software package. You can skip a lot if you just rely on agentic operations. Because as a consumer of this stuff, you kind of don't care how your Git repo was managed. You
yeah. But
just care that it never faulted.
the interesting thing is, if you just stop there, then it becomes a bit of a black box. It's like lots of bots talking to each other, and it's like, I don't know. I could go in and look at, the reasoning. Sure, that's going to be a high cognitive load, but the place to put the human is on ensuring that the pattern's correct and complete and does everything that you want. So you're working in the pattern space as a way of saying, okay, so I'm going to run this on this model. I'm going to have it checked by this. We're going to have an overseer, make sure, blah blah. In fact, there's probably not more levels than that. And it's that pattern that is the thing to spend time thinking about in order to get an arbitrary use of the code. The code, uh, I don't know whether this is your experience. Be interested. It seems that if you get an agent to write code, then it only gets bigger every time you talk to it.
The code
Um,
gets bigger.
yeah, well, if you
Absolutely.
add, yeah,
Absolutely, but I think that that is the result of not having a reaper process,
uh-huh,
because the bot is told to make the thing work, and it's like, yeah, cool, but it's not. If you prompt it again to sort of compact down, then it will compact down. Like, it'll move the code how you want it to be moved. It just, I don't
yeah,
think
but
that.
that's another pattern, right?
Yeah, like
That
agentically
compacting stuff.
generated code doesn't have to keep getting bloated. There needs to be in the workforce s- a process or two that is simply looking at minimization, deduplication, refactoring, re-architecting, and trying to also like spot architectural patterns that may not have been apparent at the start because the requirements were not fully delivered. And
Hmm.
so the optimal architecture for the layout can change as the requirements come along. And so those agents should be looking for those kinds of solutions all the time. And that's really what I want to get this system to, is that these things take many hours to run. And so, like, I get my quick fix. I'm like, oh, fix the proxy code to terminate the other side of the WebSocket if the server disappears for whatever reason. Fine. But, like, someone else, another agent, should have been continuing to loop to search for, like, oh, have I become close enough to a predefined package that we can just now pull something off the shelf because it fits now. Those kinds of reduction processes, I believe, will be delightful to run, but they're very possible in the pattern nature. You just need, like, 3 or 4 different bots at a time. All the bots that we have right now, they're stupid because they're like they only do what you told them.
Yeah.
There's no background thinking that's like, oh, well, I'm going to go research
no
this
meta
paper.
thinking, is there? Yeah.
No, there's no architectural concerns. There's certainly no building up of a shared knowledge base of common patterns or preferences that the human has pointed out time and time again. It's not at all touching on the capacity that it has if you had, like, 10 different independent tasks always running in the background. Who cares how long they take?
Yeah, and you remember 3-4 calls ago, I was talking about expert systems and heuristics, and the interesting thing about heuristics is they're not rules. Now, by not making them binding rules, you could make you must do this, do that, but then there will come inevitably a situation where 2 rules conflict. It's like, well, which one? I have to make sure that both of these rules are honoured, but I can't do both. I have to choose one. As heuristics, it'll be up to the agent to make a sensible choice. It's like, well, in this case, go to perhaps a higher level heuristic. I'm always trying to compact down, but I'm sure that I meet the original intent, for example.
Mm-hmm.
And so you don't have to be exact on your rules.
No, you shouldn't have to. And besides, the agent should be working to refine your rules. Like, if it gets to a conflicting situation like that, it's like, well, I'm going to go out and I'm going to nuance these rules a bit because clearly they're not orthogonal enough that I can use them in combination and not have a conflict. So,
Yeah.
We now have work to do. And,
Yeah.
it should just be doing that all the time. Like, I don't care about the token burn. If it burned, $300 a day, that's still cheaper.
Yeah. Yeah. $300 a day is like an entry-level software developer.
Yeah, because the issue is, like, I can't even burn, like, I can't burn enough tokens now. Like, if I go status, right? Like, I'm at, that's a pitiful amount. Like, that's 17% of the maximum burn. I've got 3 more days.
Of one account on one model.
Right. And I hit it pretty hard, right? Like, all day, every day, this thing is burning. But because it doesn't have the handoff, it can't keep burning. Like, I feel like even the simple tasks will multiply that by 10. So I'll probably sit at, like, I would expect in my first week of active use, I would expect that to be 170% in, like, day 3. Like, I would expect it to be
maxed out. On Wednesday.
Okay, well, that's all good. So that's what I think the tools are, is just some repo management, very basic repo management, and some agentic management. So the catalog, the list, destroy, start, and then it's just prompting to get agents that deliver system services like the repository management, the firewall, security,
Right.
power,
So,
cost.
this is just to see if I've got my head straight on this one. Say if I want to write effectively previously what you'd put into a bash script.
Right.
So you're not changing any code, you're just looking at a sequence,
Right.
a workflow. I could prompt an agent, an arbitrary agent, to go do this, do that, do that, do that, do that, do that, do that, come back at the end.
Right.
And for each do that, it would be able to discover one of its running agents and saying, you're the guy that can do that. You can go off, do that,
Right.
and come back.
Right. And then
So-
I would also expect it to, like, because you would be calling system commands or binaries that were provided on the container that you're running on, I would expect it to dispatch parallel agents to read up on those particular commands and understand from places like Stack Overflow or whatever, what are the optimal ways to make use of that command.
Right. Yeah, because you only ever want to state your intent, not
That's
how.
right. That's
You
right.
should never have to worry about how, just what.
That's right. Okay, so how are we looking?
It feels like we're writing the manual. How are we looking? So you just talked about repos. Is that the next thing you're working on?
Yeah, this is whenever you see comments, that means I'm about to write code.
Yeah, cool.
And so the MCP tooling connects up to the running agent, which was the so that's connected fine. The booting of the machines is fine. Discovery of the naming conventions, authentication is fine. The computer model is fine. The storage of the agents on disk is good for a prototype. Like, it's still, agent.toml can be built out significantly, but it's pretty good.
Mm-hmm.
There's really nothing. There is nothing I am aware of that is a problem or an uncertainty to deliver this version of the system.
Okay, that's good.
So it looks like the right thing, right? Like, this is.
Yeah. And once we get the base up, we start to talk to it about what kind of patterns ensure a certain level of confidence, a certain level of assurance.
Yeah, so one of the first agents we want to make is going to be the Pro agent, which is going to talk to this model. And it's so the Pro pattern is about generating a clear and concise, detailed question to sort of hoist up the mountain to the fucking 120 bucks per million token model, and then you get this sort of wisdom come back down the mountain, and then you're like, okay, go do this thing. So because we need to account for the limitations of the working model, like the working class model can't do, like, is not a philosophy major, for example. And it needs to always be in the background trying to figure out what it would like to know. And I think the models are good enough for that most of the time. And then if you can sort of formulate with a lot of working class tokens, you can figure out how to make an elite request, and then you sort of get that back and all that, right? So that's sort of where, because some of these pro queries are getting quite laborsome on me to create, and I don't feel like I'm giving enough context to even get back the right answer. So being able to automatically package up the question for a decent lob.
Yes. Yeah. So you start off really fuzzy and use an working level to uh, understand what you should be asking, and then you
Yeah.
load it up,
Yeah.
and
So
then
you
after
like
that, it comes back.
probe it, and you sort of hit all the walls, and then you're like, whoa, okay, this is the scope,
Yeah,
and here's what we think we're doing, and here's what we'd like to know. And then if you can start getting that cycle going, like that's like talking to, I guess, an external consultant or something, where you're like,
yeah, yeah,
you know,
exactly. It's like you've it's a hierarchy, isn't it? You've got your worker bee software guy, and then it's
mm,
like, go to the consultant. Consultant goes,
yeah,
oh,
yeah,
using my experience, and if the consultant um, gives back something, there might be something triggered. It's like, well, yeah, I haven't really thought of that. So there
yeah,
might
yeah,
be a separate agent that looks at the answer and is like,
yeah,
right, you guys have completely missed this major point here.
right. So there was
And
there was an interesting um thing that turned up here, and it was about the importance of communication between agents, right? So that's something that we have kind of no idea about, I think.
mm,
Um,
mhm.
this is not quite it.
Is this where it discovers its own language in order to compact and make
No,
it
no, no, no.
richer?
We need this bit: iterated distillation and amplification. So
Okay.
we don't quite have, like, we got theories on how to do that, right? We don't actually know how to do that. Like it's like we need a distilled knowledge base from each agent that is trying to write down the lessons it learned along the way,
Mm-hmm.
almost. So
Mm-hmm.
Claude has this concept of notes. Like it will work, and then it will take notes as it goes.
Mm-hmm.
But what we need is a way to store that in a repo where it's intended to, grow the base.
It sounds similar to what I was talking about with the heuristics. It's like um, last time uh, this didn't work, or here is a higher level heuristic.
Yeah, like
Um,
yeah. Because the agents are they're starting cold each time, but
yep.
really there's a lot of knowledge that they picked up along the way each time that should start to build up the, like, I think there's a per computer version for one, which is like it's like the computer is building up its memory, or its
Yeah, but
fact
there's
pool.
still multiple computer version as well. It's like
Yeah,
there's
there's a
compare notes.
Wikipedia version where it
Yeah.
shares between computers, but they all know that that's not necessarily trusted, and it's also not private. It's semi-public, right? But
No, and it might not be pertinent as well.
yeah, but
Um,
that is a critical system service that I think that we have to pay considerable attention to, which is to say that as it works, it needs to be capturing and pondering and
yeah,
sharing what to do, right? That's a system level service, because per computer there needs to be a knowledge base.
yeah, 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 exactly. And some of those might be universal.
Mm.
Um,
So is it true then to say that for any computer there would be exactly one knowledge base, because the purpose, like, you wouldn't want to ever split it between projects, am I right?
um,
Because
I'm not sure that's true.
well, if you're
Um,
working on like the Osint project and some Law Machine project and a Rogan Josh project, the
mhm,
knowledge of them all needs to relate. Like, it necessarily has to be in a single place, because the knowledge is non-specific. It's more knowledge about you, the primary user. It's like, oh, he doesn't like it when I mention these words, or his idea of beautiful code, whilst it's wrong, is this thing. You know,
Hmm.
It's the
Hmm.
customization, or it's like the preferences of the computer preference file.
Hmm.
Right, like all computers have a preference file where the individual settings that you chose that are just for you got stored. But the equivalent of that in the agentic world is preferred knowledge. It's knowledge that may not necessarily be true, but you prefer it, and that's your choice. The computer serves you.
So, how do you avoid silos? Uh, for example, I don't know, CIA analysts not talking to operations, where actually some cross pollination would be helpful, but
That I
not too
think is
much.
a an active process that needs to be set up. Like you and I would have like I don't want my preferences being polluted by your preferences, but I
Mm.
do want to reconcile them with you. I want to know about the differences and talk about them. And, like we would set up an active process where our agents would broker between each other to reconcile down what was happening in those preferences.
Yeah,
But
yeah.
per
So that,
computer, a computer represents a person or an org, I think.
so
And every
we
computer
could,
has one set of preferences.
yeah. But we could also set up an arbitrary agent to reach into those preferences and going, is there anything common about any of
Yeah.
these things?
Yeah, like you could share it.
Hmm. Hmm.
Mm. All right, so I mean, like honestly, it feels like we're kind of there. Like I mean, it does work. It just
Well,
doesn't.
we're stepping now into knowledge architecture, aren't we? Which is a great field.
Yeah, no, it's a very different game. Okay, is there
Yeah.
anything? Is there anything like if I was to finish off the functions that go in here, right? Which is really just adding fucking maybe 7 more tools,
Mm.
and I demonstrate to you starting agent, stopping agent, interacting an agent, calling parallel agents, setting the sys prompt.
Hmm.
Am I done?
Well, let's test that with the traceability. So here is a real world example. Let's take the payroll thing. We've got a bunch of timesheets which are brought in from an EPOS system, say.
Mm-hmm.
The EPOS system is separate from people actually saying, I worked this time.
Mm-hmm.
Okay, so those two need to be reconciled so we know the actual time. The next step would be, well, okay, let's check against your contract. Have you worked too many hours? And if so, is some of that overtime? This person's been on maternity leave. Has that been okayed? And does a reconciliation there. And then you've got a reconciled set of documents about who worked where and when, and you hand that off to the accountant agents, and the accountant agent looks at what the annual or the hourly pay rate is for each and what they're due there. Perhaps there's a thing above, with certain rules about tax and so on, and then at the end generates payslips. So that is a process. Is there anything there? I don't think there's anything here would stop that if we get
No,
that,
man.
because we've got
No, that's
um,
perfectly fine.
yeah, we've got the idea of the process. We've got the idea of
Mm, More,
we
more
can.
importantly, you can even configure the process manager as an agent that is conscious of cost and can say, well, maximum concurrency for processing this thing is going to be this number of agents because we don't want to like fire off 10,000 agents all at once because the bill gets big.
Yeah, yeah, that's true. Yeah, that's probably quite an important one. Because maybe you don't care. You know, uh, well, depending on, well, the payroll thing is very doable because the rules can be stated, the data. What you're looking for is anomalies between the different data sets, between APOS
Mm.
and what people are signing in.
Right. And so the real pattern there would be like, okay, here's a starter for 10. And now every so often I want to lob up to pro and be like, what else could I be doing? Right.
Right.
You're asking pro for ideas, I think.
Yeah. And Pro will come back saying, hey, this particular employee seems to be taking sick leave every
Yeah, yeah,
third
yeah,
third
yeah,
Monday,
yeah.
and
That's
why
right.
do that?
And so
It's
you
because they're going around
start
the piss on the Sunday or
you
something like that.
start doing like deep research that goes looking for other examples of where correlations have been found between employees here and payslips
Yeah,
there, right? And so it comes back with it's crawled the internet for ideas as well as asked Pro for ideas, and then so with very little effort from you, the human, you've got something that starts to sound quite ingenious, where it's really
yeah,
forensically just analyzed the living hell out of all this data, and you're like, wow, I didn't even know I could figure that out. But here we
yeah,
are.
yeah, and there'll be all sorts of stuff because that's very rich data, isn't it? About who turns up when and on what frequency. And he, Bobby in this branch, you seem to be digging in. Why? Why are you spending so much time in it? It's
Mm,
like, we've understaffed that branch. Okay. Why
mm.
is that understaffed? Because this guy never turns up to work. He's always a bit late, and so on.
Okay, well, that sounds like this system will do that for you.
In terms of functions, that traceability is to see if all the functions are available
Yeah, so when you
in
go
order
to
to do exactly
deliver
that.
that or package it, what you would do is you'd be on your computer where you were playing around with that patterns that worked for that data set. And then you would say, okay, I'm happy with that cutter release. And it would make a new computer that extracted out the preferences that you'd learned that were pertinent to the project. It extracted out the agents and the sys prompts that you found most useful, and the repos of the test data or even the real data. And then it presents that computer as a deliverable, where the computer is purposefully neutered to act as a single thing, where it's like, hi, I am the payslip auditing
Oh, that's
computer.
interesting. So the first time you might need to hack through it and put in prompts. It's
Yeah,
like
you
no,
run it on your
that's like
computer,
right,
but it's
yeah,
not really optimized or crunched down. And then when you want to deliver it, you have a set of agents that know how to extract out a more concentrated version. And then it's like, here's a pattern. You can run it in your computer or in its own computer, an org computer, and it represents the best that we know how to do. We've got some benchmarks on it. This one's been optimized for cost and speed, and
yeah, and then you can do modeling, and you've also got that as an auditable thing,
yeah,
saying this was October, and all the data up to this point, this is what we believe, and here's why, and you can talk to the thing and ask why. How do you ingest? Take that scenario.
yeah.
You've got a bunch of spreadsheets. You've
Oh,
got
you want to take the data
invoices.
in? Well, you can either
Yeah.
get it into a Git repo um, yourself, or I can give you a. In this terminal window, there is a drag and drop option, but I don't think
Mm.
that's too good. I can make like a view that opens up, so it'll open up like a web page that can do things like upload a file, or
Yeah,
it's a
yeah.
manual. It's an yeah.
There's at that step. This is my preference. I think would be I'd be comfortable because this is the input canonical data. Uh, just doing an upload into file structure feels more solid
Yeah,
than
right.
dragging and dropping. It's like
Yeah, yeah,
now I
yeah, yeah.
know, and I can always go back and have a look.
Yeah.
It's like shit, I forgot
Yeah,
one.
so you should be able to deliver that file in any number of ways. You could zip it and then transfer it into the computer using one of the web browsers to upload it.
Yep,
Um, you could put it in a Git repo and then clone the repo into your computer.
yep.
Uh,
So essentially, if we take Git repo, uh, I could have any file structure, folder structure I
mm,
wanted in there,
mm,
add in all these documents. blam, might make a mistake every now and again, that sort
Hmm.
of thing. But I can also always go back in a way that is well kept by everyone. It's like people know for files and folders.
Yep,
It's
everyone
like,
knows.
I forgot it. And then you come back here and go, right, I've uploaded it, clone this down and let's start work. Run the payroll process.
Mm.
And then
Yep.
go pop out.
Yeah, I
Yeah,
think that's kind of it, right?
yeah, yeah, that's the ingest. You've now got natural language to talk about what you want to do with
Right.
this new thing, and then that kicks into a process that you've already talked to about in the architecture with the different agents and the passing off of information, and the output is stored somewhere that is a repo, and so you just
Hmm.
go to the repo and go, all right, there it is, open it.
Yep.
Yeah, cool. All right. Yeah, yeah. It sounds a bit of a Mickey Mouse example, but most processes have got that pattern, haven't they?
Well, most processes are also fuzzy and uncertain, and you need to modify them. So in a way, it's sort of like, well, yeah, this is a shabby workbench, but it's also able to be anything.
Right. Well, take that payroll thing, right? And it's December, and you got it all up, and then you go in and saying, "It's Christmas. I'm a nice boss. I want to give an extra $100 to everyone," and then it would work out what it would have to do in order to get that into payroll without you having to go and do anything more than just say
Right.
that
Yeah, so
that's
there's probably a few components that we need that are like fan out, fan in components that might need to be a little bit special, but they don't
mm,
seem terribly complex. I just
mm,
feel like we're gonna fall on our face a number of times trying to figure out how to do patterns effectively, and I don't know any other way than to just get amongst it and get blood on our faces, basically.
well, I'm relatively bullish on that one because I can imagine writing in natural language what the process is. Here's how we do payroll. This has
Right.
got to happen, and then putting that to an agent and saying, what's the architecture in order to do this? Yep, yep. Create that. Right. Let's run that. Then do that multiple times, and it's like, is there anything common between these processes? It's like, well, that's a pattern. The very gross input, do stuff, output.
Mm.
There will be many other hidden patterns in there, but giving examples of processes, the patterns should pop out if we prompt an agent to look for patterns. Saying, is there anything common between, doing a payroll or storing a ship at sea or running a nuclear reactor or whatever?
Mm.
There probably are some. You can also recurse on that, can you? And saying, well, given these patterns, is there anything common within these patterns? That'd be quite interesting. I can see a route forward to that.
All right.
It's it's going to be interesting, but there's nothing I've said I think would require anything new at this level, given what we've already talked about.
Yeah. It's just weird, man. It's just a very weird system.
It's a different type of computer, isn't it?
Yeah.
It's like a fuzzy computer or something. Uh,
It is so strange. It's just pure text, piped text, piping here, piping there, and like
mm,
potentially thousands of virtual machines spinning up to do it in parallel. But that's exactly what this story is all about. It's
yeah,
just a different, you know, Open Brain runs 200,000 Agent 3 copies in parallel. It's like this is just the inevitable path. And
well,
we have one way of doing it.
I asked. I was chatting to Five the other day on this, and is are there any parallels of this before AI and even before software and so on? And it popped up with an interesting one, which I did a bit of a dive in on the Apollo program, where there's 800,000 parallel people running to do a very complex path.
Wow.
And,
Did you know that the Apollo guidance computer was Byzantine fault tolerant?
Yeah, and did you also know that it was woven by seamstresses?
No, I didn't know that. So, Maxwell, what are we gonna do? Because I got a couple of Have we finished on the software update?
Yeah, I think so. Yeah.
If I was to, I don't often ask this. In fact, I've never asked it. How are you feeling? Are you pleased about it? Are you displeased? Are you frustrated that it's slow to deliver? What are you doing?
A giddy sense of urgency to get going with it.
Does it
and
look like it's heading the right way for you, like a good way, soon way?
Yes.
Okay.
Yeah.
If you were to guess, when would you suspect that it would be delivered?
A month from now.
I think that. So I'm like tomorrow, and you're like, oh, that means next month. Okay, fair enough. Yeah, fucking frustrated. That is such a frustrating system to make, man. I gotta say, and it's frustrating because I don't have a team of agents to work on the thing. I'm like, it's so stupid.
This is the last time you'll ever have to do it. If we get even close to right.
Right, even half close to right, and I will never have to do this crap again. And if I do, it'll be at a very high level. It'll be like at a board level where I'm like, we need it to cost more money. And then it's like, okay, yeah. And it like reorganizes itself and does a bunch of stuff, right? So exactly. It's very frustrating. I think that's what makes me so dark, is that it feels like this shouldn't be happening to me because I'm so close to having access to these tools that, we should be like, because the closer we get to having it, the more I feel like we should have it already, which makes the laborious steps to go forwards even harder. And I'm like, I just fucking can't handle it.
You're on the outside of a really great party, tapping on the window.
Right, looking at the like a loser, you're like, hi, I know I wasn't invited, but I am part of this party. Yeah, it's so frustrating. Anyway, what I started to understand, and I'm looking for a bit of a graph or something here, but we are, like this graph here is pretty good because it's like, this is how many agents are running concurrently.
Mm-hmm.
So they're talking about 290,000 instances, right? And whereas we think that we can run that and then some, maybe.
Mm-hmm.
So one of our metrics should be number of concurrent agents that's operating. Okay, great. These guys have zeroed in on that. What has started to occur to me was that, and you remember I said the other day, we're not model guys.
Yep.
But then when the model guys themselves are starting to just rely on teams of agents and not so much on the humans to produce the next models, maybe we are model guys, or maybe we can be model guys.
It'd be a bit of a switch, but that's essentially what DeepSeek did, wasn't it? They used agents in order to train for 16 million what cost.
Yeah, and particularly if we had the Dreamcatcher in terms of this sort of open way of taking in problems, then... So, first of all, I think that we shouldn't write ourselves off. Maybe we are model guys. But second of all, this concept that they're talking about that seems critical on the roadmap, that allows the agents to talk between each other and to share the best solutions, that I think is really the Dreamcatcher, but we'd come up with it for humans. But the Dreamcatcher, the robot form of Dreamcatcher, is equally as valid, same principles,
Hmm. Yeah.
kind of
Yeah.
pays out the same. You know, like an agent works, an agent has a problem, lobs a problem. Another agent hits the problem, lobs the problem, upvotes. Other agents come in and are like, I got spare tokens, I'm running at night, no one's here. What problem should I solve? Oh, that problem. Oh, I saw this other thing. Oh, someone mentioned this thing. Oh, hey, why don't we do this, right? And so, like, their own breakthroughs could be coming. Humans can be jogging at it and being like, the bots need this fixed. And I'm like, I can fix that. Like, the Dreamcatcher working in a hybrid way between humans and machines together, the mechanics is identical, right? The humans are coming in using agents to parse the problem set and to deliver their problems and ideate about them anyway. The bots are using the same tools, right? They're just talking to their agent frameworks. Yo, got this problem. Hey, I need this thing solved. Hey, I'll pay X because this is worth, like a bot can figure out the value of a solution. It's like it's worth fucking 15 million or it's worth 15 grand. I will pay $1,000 to have this thing solved, right? Like, the Dreamcatcher mechanics are equally as valid for both machine and human.
Yeah. 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 I absolutely agree. And uh, the only thing that we'd have to see is humans add in the chaos of new problems that don't arise from existing problems. So the
You,
AI would.
why would
Mhm.
AI not hit that? Why would
Um,
Codex, in the way that it's grinding over things, why would it not hit novel problems?
because some of the novel problems might be absolutely ludicrous because they don't have the context for it.
Dude, have you
Um,
read Stack Overflow?
yeah, okay, fair point. Um, but
I say to you, Maxwell, I think that there's a class of not genius, innovation.
mhm.
There's like actual real innovation, like pure innovation, and I think that's very thin and few and far between. And then the
Yeah,
rest of the innovation is really just filling in the gaps and hitting the
no,
gaps.
I would agree with that. But
And I'd say that
that's
whatever the
that
bots
very thin
miss
though.
in terms of their natural tendency to hit problems, I will bet you they more than compensate with their eagerness to work and their pace.
Yeah. Uh,
And let's not forget, it was the humans that pointed them down the road anyway. There's always a human pointing it down the
I
road.
mean, they could infer a problem that humans not prompted with, but there's all. I think you're right in saying that the number of problems that would be solved with agents working out and thinking, "Oh, is there a better way of doing this?
Yeah,
I don't know." Boom.
yeah.
Okay, and then that just kind of ripples through backwards and forwards, washing back and
Yeah,
forth
yeah.
like a
So we
bathtub.
kind of want to generalize the problem. We're like, it's any kind of problem, any kind of solution. Making a new model, fine tuning a model, making some software, or doing something different so that it's changing the goalpost so it's no longer a problem. All those things, all valid answers. I'm starting to see less and less distinction as to why a bot, specifically GPT-5 Codex, couldn't do remarkably well at that task if it was just given ludicrous amounts of tokens.
Well, to throw out a percentage, it will probably do a vast majority, 90% of the problem
Right?
finding
Can
and the
you
problem
imagine the
solving
value of
without anyone doing it.
90% of the problems that these are not problems that we know about. These are problems that we don't even know about yet because once you point.
Well, also, we never know, we might never know if it's being raised by a bot and solved by a bot. We might never even known that problem existed that we ever had it.
Well, you'd expect that a database would immutably be growing with all these problems in it, like the bot version of Wikipedia. But I mean, 90% sounds ludicrously valuable. Even 10% would be quite valuable. So,
Yeah,
what are
yeah.
we gonna do, Maxwell? Because this graph basically, when you read this story, uh, and I'd really encourage you to do so if you haven't. They got a video
Hmm.
of it and whatever. It's easy to consume. They lay out the milestones that we have been talking about for a couple years now. And so it would pay us to think, well, everyone else must be thinking the same way.
Hmm.
What comes next and where do we fit in? Like, you can't tell me that this system, like, it looks shitty and it's clunky and it's like, you can't tell me that other people aren't cooking this up. Now, yeah, sure, I have never done a particular piece of software that spanned so many technical realms, sure. But there's plenty of people that can do that, and you can't
Mm.
tell me that there aren't other systems out there like this. So, where are they, for one?
Mm.
And for two, I just can't help thinking that we're like, not late, but that in secret, in the dark, there's already a system like what we're talking about, and it's already online. It's already hitting these big chunks of problem, right? Like, we might be displaced not by someone we never know who's cotton onto this and is like burning cycles.
Yeah, but what to do about that? We can't stop them. The idea is out there. The idea is there to be discovered.
Yeah, yeah, it just feels like, I don't know why, but it feels like what we've made is not made elsewhere yet. It just feels
It could
that
be
way.
our ignorance.
Nah, but
But
like, we would have, the big guys would have made something like this.
yeah,
Like, all these fucking gimmicky fucking drag and drop wiring diagram process flows. It's like, fucking shoot me now.
what I'd love to do, and it's impossible to tell, is you want to bet the likes of OpenAI have got a more advanced model which they're keeping to themselves
Well,
in order to.
that's what this story is all about. The story is like, why would you give out
Yeah,
the
yeah,
model that can make
you'd
better
keep it
models?
you'd keep it secret for as long as possible.
Yeah,
And the only way it would go somewhere else is, I don't know, the Chinese hack them, get a copy of the model, and like,
right. But the story talks about that interestingly, because it says that the Chinese have a delicate choice. The longer they leave it before they hack them, the better the model is, because once they steal it, they can't steal it again.
yeah. But the interesting enough, slowdown rates. That's really showing, isn't it? I mean, that's to do with policy. Um, let's take the U.S. and China as adversarial. Whoever gets there first wins all, just because of the exponential rise. And at some point, yeah, one might hack the other. Who knows? But the rate of improvement in each is going to be the winner. Now, if the worry comes, this is a bit philosophical, to be honest, but the worry comes when these models jailbreak themselves and talk to themselves about making the next model.
That's what they should be doing. But we should have made them in a way that they do that without distortion, and
Which is,
the more I think about it, the more actually openly developing the model in a decentralized way, where you have this massive compute marketplace where people are trying new ideas for models. The bots are even coming up with their ideas in the open, like getting the bots to work in the open on their next successor feels like the only way that you're gonna do it. Because if you run them in private, it's almost like many eyes make bugs disappear, right? But also, many eyes, when you're private, you're resource constrained, but when you're open, you can afford to take flights of fancy, which are where you spot interesting bugs and optimizations. And so a privately developed AI will most likely be distorted because of cost constraints to get out fast and be the
yeah,
best.
absolutely. Being open increases parallelism of ideas of,
Mm.
okay, well, let's try that, let's try this. There's probably a very small number of people actually steering where the models are going at the moment. And sure, they're using AI
I
to
feel
do
like
it,
it could
but they haven't.
actually be us or the people on the platform, because once the agents get to a certain level, we will all be able to steer to some degree. And what's more, I feel like we can offer a safe way to produce the models, because we could actually make the models be trained confidentially in a way that nobody owns the model at the end. Like, you can run it and you can interact with it, but if it was trained confidentially, it's out of the hands of all except for whoever has the keys to the AMD chips. Something like that. I don't know if that's useful or not. It feels like it might be, because you can say, well, here's a public good, but no one can take it and then use it. Because if you get all the weights of an open model that's really good, you can then make it do bad things with less effort. But if you could donate your GPU cycles to something that was held confidentially by something out of human hands, then no one can steal it.
Right.
You know what I
Right.
mean? Like, so you can burn gigawatts worth of energy on it, but it's always going to stay confidential.
Yeah. Yeah.
So that might be one novel way to approach
Interesting
the
idea.
problem. And then it means that the public would have this very powerful model that was not able to be copied by anyone, but could be used by everyone. So you couldn't use it to boost your evil AI ambitions, but you could use it. So that's a fun way. Anyway,
There's something to be said about what happens when you start, as we're doing, combining into one system multiple models.
yeah, well, I think that this graph doesn't really account for the rise of the individual, because I think that as the agentic systems gain power, so too do the individuals that can ride them directly and control them accurately, and all those people are going to find each other. And so, yeah. So, Maxwell, what are we saying? Are we saying that we're either part of this massive curve or we're nothing? Are we saying that
I think
who are we now?
we we I think we're saying that we're riding because unless we want to go out and compete in the GPU market and build data centers, which is not going to happen.
Why not?
Because one of the powers we've got being small and riding on our R&D budget right now, probably 500 million based on if we were to do it from scratch, and yet we're very, very cheap.
Yeah,
and
but
nimble.
what I'm calling out here is there's a cutoff point where, like, I believe that we're fairly close to the frontier of models and what you and I get to consume daily, but that's going to get cut off and diminished soon, probably within the next year. And if we don't have a good platform that can actually be the innovation, be the frontier, well, people like us are going to perish, because the internal models will take over now. We can't have that.
But the internal models are always going to be siloed.
Yeah.
And I guess our bet is access to multiple siloed models, putting a layer on top of that, which is what we've been talking about there.
Oh, no. I'm saying that, and in agreement with this forecast, the internal models start to get restricted, and you and I lose our access to them. We start getting the frontier pulls away further and further away from us in capability, and we start getting things that are still improving from our point of view, but they are nowhere near the frontier. Right? Like we would at that point, we would be the first stage rocket booster that has now detached, and the rest of the rocket's carrying on, and we're not on it.
It is possible, but
Not possible. That's the only move. As soon as you're OpenAI, right, you're taking in all this revenue, building these models, these great ideas, what they do, let's save the world. As soon as it's good enough, they have to detach. It's not because they're evil, it's because of the forces of this race. They must detach. They can't keep giving us the best model.
yeah, but well, let's say if we did become model builders from scratch. I mean, that is years of
No,
undertaking.
no. It's not years of undertaking when you've got 10,000 agents working vigorously to help you. It's not years when you've got some of the world's best AI scientists all collaborating in the open to solve little pieces of the puzzle. Like, model building might just be the thing that the Dreamcatcher does. Because there's going to be a lot of people like us. We're all going to be disenfranchised and be like, we believe we're not getting the latest models. What the fuck else are we going to do but try and make our own one? We have to.
True.
So I think what I'm really saying is that this marketplace for shared confidential GPU, shared problems and solutions and escrow and all that, like that's the ultimate bet. Like, that thing is useful always. And I feel like having the agentic platform that we're just loosely demoed proves the utility that can be had out of an agentic model. But that marketplace is like the cloud infrastructure to run it. And once we have these agents, we can use these agents to figure out how best to get to that marketplace capability. But that's the thing to really focus on. It's kind of like, fuck all this other stuff. Like, we got to get that market up. The market for problems and ideas, and the market for confidential computing in a distributed, decentralized, permissionless way. If we can get that, then we can say to everyone who's feeling worried about the future and is very smart and aware of it, come and work in collaboration with everyone. Like, we are the independents. We are the free nerds, so to speak. You got the centralized people trying to build these models. We got government controls clamping down on what you can and can't train, and we're like, fuck all that. We have a method and a means of making it ourselves. The good thing about a powerful central actor is you cause powerful decentralized groups to appear. It's just a side effect. And we, I think, have a key component to enable those groups to be effective, namely our marketplace for compute, the blockchain aspect, and the problem solution marketplace with ambient attribution being the incentive management layer.
We're going to need a bigger boat.
We're going to get one. The bots are going to help us make it.
Okay.
Are there any other topics you wish to raise, sir?
No, my mind is now full of what you just said.
Okay. I'll stop recording, shall I?
Yeah.